Hello everyone, this video is a continuation of a discussion about combinations. In this video we'll talk about a formula for how to find the number of combinations, and then we'll practice using that formula in a variety of examples. Alright, so the first thing that we can do is use listing to compare the number of permutations and combinations, and what we're going to do is eventually try to develop a formula based on the permutations one that we know to somehow get a formula for the number of combinations, since they are very closely related. So let's try this exercise. Given 4 housemates, Ruth, Elaine, Emma, and Jasmine, list the permutations and combinations when you are selecting 2 of them. Okay, so permutations, we'll start with that. So we want to choose 2 out of 4 and then arrange them in different orders. All right, so we could choose, and I'll just use first initials here. So we've got Ruth and maybe Elaine. We've got Elaine and Emma, Emma and Jasmine. We could do Ruth and Emma, Ruth and Jasmine. And we could do, let's see, Elaine and Jasmine. And I think that's all of them. Right now, these are all of the ones where we didn't really look at order, right? But remember that the order of these can be switched. So when we choose Ruth and Elaine, it could have also been Elaine and Ruth, right? And Elaine and Emma could have been Emma and then Elaine. Okay, and then the same thing for all of these options. These could all be in a different order. JR and Elaine and Jasmine could be Jasmine and Elaine. Okay, so which of these are the permutations? Well, all of these are permutations. And then the combinations, what we want to do is just look at one list of these. Right, so for instance, if we just picked this group, right, so a combination does not look at order. So this option of choosing Elaine and then Ruth would be the same as choosing Ruth and then Elaine, right? If we were just choosing people for tickets to a concert, like we talked about in a previous example, then it wouldn't really matter who was picked first. It's still both Elaine and Ruth that are going to the concert. Right. So we end up with only half as many combinations as permutations. Okay, try this one. If you're choosing 3 out of 4 friends, Bill, Colin, Demetrius, Ethan, list all permutations and combinations. Alright, so I'm going to leave this for you to do as an exercise, and then we'll use these 2 to try to verify and see where this formula comes from for combinations. But here's the gist. If you're choosing 3 out of 4 friends, let's say you choose Bill, Colin, and Demetrius. Okay, well then when you're listing combinations, that's it. You would move on from there, do other combinations. So in another group of 3 that's not exactly Bill, Colin, and Demetrius, right? Maybe Colin, Demetrius, and Ethan would be a second combination. But if you're looking at permutations, then we also have to look at arrangements every time we have one of these combinations. So along with choosing Bill, Colin, and Demetrius, we would also have, all right, in different orders. So maybe Bill, Demetrius, Colin, or Colin could have been chosen first. Oops. Okay, 2 ways for Colin to be chosen first. And also Demetrius could have been chosen first. Okay, so try that and see if you can list out all of the different possible permutations. Okay, so that would be all of these arrangements, and then repeat that again for every different combination that you have, and then you should end up with a list of combinations as well. Right? And then notice how many there are, how many combinations, and how many permutations. Now once you've done that, we have 2 different examples. In this first one, if you count, we had 12 permutations and 6 combinations. Right? And then you'll have your numbers from this example. And then once you've done that, go on to the next part of this video, and we'll talk about the formula for combinations. Okay, so here's the formula for combinations. All right, we have a calculator key NCR, C for combinations. N stands for the total number of objects. Right, so the pool of objects or people to choose from. And then R still stands for the ones that are being picked or chosen. So some sort of a selection. And then the formula is very similar to the permutations formula, and you may remember, I'll write this one down. Permutations formula was n factorial over n minus r factorial. And here the only difference for a combination is that we have an extra factor of r factorial in the denominator. All right, well, why is that the case? If you think back to when we did permutations of like objects, it's similar to that. So let's say in the previous example, all right, you have Bill, Colin, and Demetrius. All right, so if we're just looking at combinations, this represents one combination. But if we look at the permutations, there were 5 other arrangements, or in total 6 arrangements that represented the number of permutations that went with that one group of 3 people. So we have one combination, but 6 permutations. All right, well, why is it 6? Because we're looking at how many ways there are to arrange those 3 things, or 3 factorial. All right, and 3 factorial is 6. So if we wanted to see how many combinations there are, what we need to do is find the total arrangements. Right, that's this part of the formula, the permutations. Right, and then we just need to divide by how many ways there are to arrange each of those different things. All right, so let's try it out with your previous example. All right, hopefully you found when listing that there were 24 different permutations. All right, but only 4 different combinations. All right, so if we looked at this formula, all right, here's the number of permutations. This is 24. Right, and then combinations, all right, we want to divide by the number of ways there are to arrange the 3 things that were chosen, because we have 4 people, and we're trying to choose 3 of them, right? So we want 24 divided by the 6 ways to arrange those 3 people, and that does give 4, which hopefully you found was the number of combinations. All right, let's try another example. When we talked about the problem with choosing people from that group of housemates, Ruth, Elaine, Ama, and Jasmine, right? And we had 4 people, and we wanted to choose 2 of them. Right? Well, we found by listing that there were 12 different permutations and only 6 different combinations. Right? So if you think about the permutations formula, or even just the fundamental counting principle, when you're going to choose your 2 people, if we just look at arrangements, right, arrange 2 people, well, there's 4 people who could be in the first spot, 3 people who could be in the second, and then multiply, and that gives you 12 different arrangements or permutations. Right? But we saw that for every option that we picked, like Ruth and Elaine, the permutations was also counting in the reverse order of that, Elaine and Ruth. Right? So since we have 2 people here, there are only 2 different ways to arrange each of those selections, right? Or 2 factorial. Right? So now when we divide, we're dividing by the number of ways to arrange the people that were picked. So number of ways to arrange the R people. Or in this case, 2 factorial. All right, and then that gave the 6 different combinations. All right. So now think about an example where we would have a lot more people. Let's say maybe 10 people. 10 people, and then we want to choose 5. Right. Well, we know that the way to arrange 5 out of those 10 people, all right, that would be 10 times 9 times 8 times 7 times 6. Okay, so that considers all of the different arrangements of 5 out of 10 people. But then let's say we've chosen people, persons number 1, 3, 6, 8, and 9. Right? Well, this number, the number of arrangements, takes into account all of the different arrangements for each of those groups of 5. So it's also counting, like if we just switch some of these, 1, 6, 3, 9, 8, or 9, 8, 6, 1, 3. Right? And what we want to do is just eliminate all of those repeats. Well, we need to know how many repeats there are, or in other words, for any group of 5, how many ways are there to arrange those 5 choices. Right? And again, the answer is another factorial. It's 5 factorial. Right? Or 5 times 4 times 3 times 2 times 1. Okay, so if we do the math on this, there would be 30,240 permutations, but then dividing, there are only 252 combinations. Okay, so let's try this out. Use the combination rule to decide how many combinations of 4 objects there are taken 2 at a time. Okay, 4C2. Right? So we have a couple different options. Right, one, you can just use the button in your calculator. All right, so you would do 4 and then hit the NCR key, and then the number 2. And just a reminder, if you have any of the graphing calculators, you want to hit math. I'm thinking mostly of the TIs here. All right, hit math, and then you should see an option for PRB for probability. And then underneath that you have all of your factorial key, the permutations key, combinations key. If you have a TI scientific calculator, then you're just going to see this PRB button right on the calculator itself, and then same thing, find the combinations key. Okay, so then, alright, so you've got that option. If you don't have that key and you choose to use the formula, then we know that NCR is n factorial over n minus r factorial, and then r factorial. So you would fill in the number. So this would be 4 factorial divided by 4 minus 2 factorial, and then an extra 2 factorial. All right, and then sort of that third way, based on the fundamental counting principle, you're just going to find the number of ways to arrange 2 people, so 4 times 3. Right? And then we're adding in an extra division step, dividing by the number of ways to arrange 2 things, or 2 times 1. Okay? So either way, you should end up here with the same thing, and it should be 6. All right, another combinations example. How many combinations of 8 objects are there taken 5 at a time? 8C5. Okay, so you've got the calculator key, should be okay with that. The formula would be 8 factorial over, in parentheses, 8 minus 5 factorial, and then 5 factorial. And then writing this out by hand, you would have, we're choosing 5 different things, so 8 times 7 times 6 times 5 times 4, stopping at 5 different things, and then divide by the ways to arrange 5 things, 5 times 4 times 3 times 2 times 1. Okay, and whichever method you choose, you should end up with 56 different combinations. Okay, a couple word problems. When studying abroad one semester, Tran is required to visit 10 different cities. He plans to visit 3 of the 10 over a long weekend. How many different ways can he choose the 3 to visit? Assume that distance is not a factor. All right, so in other words, these are all equally likely options that he will pick. All right, so we just need to figure out what is N and what is R. All right, well, in this case, he's choosing 3 out of 10. So this is 10C3. All right, and you've got your different options to figure that out, and the answer is 120. A second one, an instructor posts a list of 8 group projects to her website. Every group is required to do 4 projects at some point during the semester. How many different ways can a group choose the 4 projects they want to do? All right, so we're choosing 4 out of 8. So this is 8, choose 4. And the answer is 70. Okay, we will stop there, and in the next video we will talk about using combinations in combination with the fundamental counting principle. So looking at more advanced problems using this same counting rule.